Good stuff. Good stuff. We did it, my friends, right here. We made it. I drink coffee to give me energy. But my poor iPhone, it cannot drink coffee. So I will plug it in. All right, my friends, we are here. We did it. Thank you so much for coming. Who's having fun? Right on. It's a good day to be alive. We have very little time and so very much to cover. So, my friends, let's get to it. First of all, as always, thank you for being here. Second of all, take note of that slide. That slide is the most important slide that you're going to see this next hour together. So please take note of that slide. While you're sitting down, you should get your phone out and take a photo. I think I'm going to take a photo with all of you in just a second anyway. So it'll be very much a similar thing, right? We're going to take photos of the slides. I'll take photos of you. It's going to be fun, okay? So we're going to take a selfie, just you, me, and the camera, okay? So when we do this, ready, steady, say open source, okay? Open source. Yeah. Good stuff. So, my friends, first of all, there's the code. If you want to follow along at home, there's that. A little bit about me. I'm online. I'm on Twitter. How many of you are on Twitter? I'm just curious. Twitter 2019. Twitter 2019. Okay, the rest of you, get on it. What are you doing? It's a great place to be. It's an open source sort of community, kind of, sort of. The point is, it's the new IRC. It's where the developers that drive the open source that powers your business are. So you should be there, okay? What about email? How many of you are using email? Who's using email? Anybody? Okay. It's okay. It's an option. You can find me on email there as well, right? I like email. It works fine. A little bit about me. My name is Josh Long. I work on the Spring team. I've been there officially for almost 10 years, unofficially for much longer than that. As part of what I do, I have videos. These are on Safari. These are like deep dive, 5, 6, 7, 8 hour long content. I have a book that I wrote called Cloud Native Java, which is available in Russian. That's kind of cool. It's also available in Korean and in Chinese and in English. I have a podcast that I do every Friday. So it came out today. The newest episode just came out today with the Spring team member. Every week it's me interviewing somebody from the ecosystem, right? And so today the episode was with Violeta Georgieva. She's from Bulgaria, right? And she's on the Spring team. She works on Netty and Tomcat and all this good stuff. And of course, every Tuesday, I do a blog called This Week in Spring, and I've been doing that for 10 years or so. And of course, I do a screencast every Wednesday called Spring Tips. It's a YouTube playlist that you can find, and there's lots of different content there. And I've got a new book called Reactive Spring, and we saw a little bit of Reactive Spring earlier today, right? Who was in the first talk with my friend Jürgen and I that we did earlier? Okay, so there we covered just a little bit of the possibilities of reactive programming. And the very first question that people often ask is, great, we've got this new asynchronous reactive world. How do I test it, right? Very, very good question. So this is the talk for that question. We're going to talk about testing today. Testing is not, I hope that testing is not a new idea for you. How many of you test your code? Right? Testing should be, everybody should be testing their code, because otherwise you don't know if it works, right? And more to the point, you don't know if it should work, right? That's a very interesting distinction there. So testing is not a new idea, but is testing fun? Is it fun? I think it depends on when you do it, right? So testing is one of those things where you should be testing, but it feels like a chore sometimes. It feels like an extra bit of work. And this is why I quite like test-driven development. How many of you do test-driven development? How many of you do that? Wow, not a lot. See, I'll bet some of you are unhappy because you have to write tests. It feels like a chore. So today, we're going to talk about test-driven development as a way to make it more fun. And the reason it makes it more fun is because it forces you to have a little bit of discipline, but it gives you a lot of good results. Remember, the goal here is to be efficient. Oh yeah, all right. All right, good stuff. The goal here is to write code and prove that it works, and then see it delivered into production. The problem is that when you write your tests afterwards, after you've written the code, it can be very depressing. It can be disappointing because you've already had that wonderful moment where you saw that the code works. Yes, it works, right? You feel very excited about this. And then you start to write the test. It's like, I already know it works. Why do I have to test it, right? We already know it does. I saw it work. It's a very disappointing thing. It's like writing documentation. That's very, it's disappointing. Nobody wants to write documentation. They want to go solve more problems. And the reason for this is because people, human beings, all of us, we like achieving. We like reaching goals. We like feeling like we're making progress. There's something about our brains that is wired a certain way. And so people exploit this. They take advantage of this truth, of this fact, this nature of human beings. And so you see this all the time. Video games today, they're designed to give you, the player, the people who are playing it, this sense of, hey, keep going. You're almost there. Keep going. You just go a little bit more and you can beat this level, right? And meanwhile, you get addicted, right? You feel very engrossed in the game. You can't stop. On the other side of the spectrum, we've seen some video games that are so very difficult, people can't beat it. And it makes them very depressed. They can't get to the next level. It makes them so depressed. Some people even do very, bad things. They hurt themselves because they feel so depressed, right? So this is what happens when you take away the ability for somebody to feel like they're making progress, right? Video games is one example, right? Jogging. Anybody here run, jog? Not me. Definitely not me. But people do, right? Jogging is a thing that people do. And the reason is because it allows them to feel like they're making progress. It's a thing that you can do that gives your brain the sense that, hey, if I just keep going, I'll get to the next horizon. I'll get to the next level. I'll get to the next landmark. And it makes it easy for people to feel very satisfied that they're making progress. Test-driven development is about that. Test-driven development gives your brain a constant stream of things that you are constantly moving towards. It's a new horizon towards which you are always moving, and towards which, with which you are always making progress. Test-driven development gives you the same euphoria, the same hit in the brain as video games, as jogging, and so on. And the reason it does this is because as soon as you write the code that is testable, as soon as you've written the test, as soon as that test is green, so is your code. Your code is done. The production code is there as well, right? As soon as that test is green, you've shipped something, basically. So there's not like, oh, I shipped it and then I have to test it. No. By testing it and by doing test-driven development, when you're done with the test, you're also done with the code. You get 2 for 1, right? And you don't have to wait. This experience of feeling engrossed by something, of feeling addicted to something, this feeling of like sitting down and just working or enjoying it or really just diving into it for a long time, this is not a new thing, right? I think most of us have been lucky enough to have this sensation. How many of you know what it is to get into the zone? To get in the zone, right? When you're programming, you sit down. Have this ever happened to you where you sit down at like 9 o'clock in the morning and then you're sitting there and you're programming and then you look up and it's dark, right? It's 9 at night somehow, right? And you were just having so much fun writing code and you're making so much progress, right? You got good music and you've managed to ignore the rest of the world and you can focus, right? This is a very nice sensation. People who play video games, same thing. They get into the zone, right? This is a very nice feeling. Our brain likes this feeling. Our brain needs this feeling. You know what the opposite of that feeling is? This is why people get so angry when they're at offices that have constant meetings, right? Because you start working and then there's another meeting. It's very disruptive. People hate that. So we're going to talk about test-driven development. We're going to talk about Spring. But all of this, I want to talk to you about all of this, and I want you to keep in mind that the goal here is to make life more fun, to feel better, right? So we're going to talk about test-driven development. Now, test-driven development has some nice benefits. When you write code that is testable, then you are, by definition, writing good code, right? Because testable code is code that can be extracted out in isolation. These are small pieces. These small pieces you can test in isolation without the rest of the application. Testable code is clean code. It's object-oriented code, right? So when you write test first, you must, by definition, you must write testable code. And this is good. You end up with a higher quality of code. So it's also, it's not just fun, it's also better for the result, better for the resulting product. It also has the effect of giving you a chance to sketch out or kind of think through what you expect the API to do. Writing the test first gives you that benefit. The question then becomes, okay, well, I'm going to write tests. How do I start, right? And people struggle with this. They don't know where to choose sort of which option. There's two options here. One is outside going inside, or inside going outside, right? So you start with a small, that's called inside, and you go out, and that's the big, right? Or do it the other way around, right? And what I mean by outside in or inside out is, do you start with the unit tests, the small little unit tests, and do you work your way up to the service? Or do you start with the service and then work your way down to the unit tests, right? And this is a very important distinction. There's no right or wrong answer. It really depends on what you're trying to achieve. Let's say that you want to write an application, and you know that you need to test lots of different things. You need to test the components, the services, the controllers, the APIs, and the end-to-end, the interactions with different systems, different components, right? All of these things are part of your tests, right? We know about the testing pyramid. The testing pyramid says, hey, at the very bottom, I want to have 80% of my tests should be fast feedback tests, very quick unit tests. And then going up, we have slower tests, like pseudo integration tests. And then at the very top, we have the end-to-end test, the smoke test, the integration test, etc. This testing pyramid it's important that we keep that testing pyramid, right? We want fast feedback. This is all about getting that hit in the brain, that feeling that we're making progress. So today, we have the question of, do I start from the outside or do I start inside? If you are working with different teams, that's one team, this is another team, this team is building one API, that team is building another, and you are both trying to solve a problem, but you're not sure about, you have to solve one thing, you have to solve another, and you know that eventually these two different APIs, these two different teams will need to integrate somewhere. But you're not too worried about the integration. If you're not too worried about the integration, then you can start inside out, right? That allows you to write code and just start working on the database, start working on the API, start working on, all the other stuff besides the integration layer. That allows two different teams to work concurrently. This is valuable, right? On the other hand, if you have a very dangerous or risky integration, if you know that this team is going to have to talk to this team's API, both APIs will need to communicate, then the integration becomes very, very dangerous. It's risky. So you want to get rid of the risk. In this case, you have the two teams work together. You design the interface, the integration API, up front. That means outside in, right? So either you start with a small team, start with a small API, working up, or you start with a big integration layer and work down. Which one you choose is up to you. My friends, today we're going to start inside out. Because I've only got one API, really, right? I don't have any scary integration with other teams. So we're going to build a new application today, my friends. And we're going to do that, of course, going here to my second favorite place on the internet, after production. We're going to build a new application here called a producer, okay? So at producer. And we're going to choose all the latest and greatest stuff here. Very good. Choose Java 13. We're going to choose the Spring Cloud Contract Verifier. We're going to choose Lombok. We're going to choose reactive MongoDB. Okay, and we're going to choose the reactive web support. Okay, so now I've got my basic service, my basic producer API. I'm going to go ahead and hit generate and load this up in my IDE. So here we are. There we are. Producer. Now, the application is just a regular application, not a big deal, just a regular service. And you saw us do something like this before. We're going to be using the reactive APIs. A lot of what we're going to talk about today also works without the reactive APIs. You don't have to have reactive. Because most people are still using JUnit 4, I'm going to get rid of the JUnit 5 support. So by default, when you use Spring Framework, when you use Spring Boot 2.2 on start.spring.io, by default, the project has an exclusion that makes it so that you are using JUnit 5. But we're going to start with JUnit 4. I have a test here. You can see that our projects generate a new test for you, right? When you go to start.spring.io, you are given a checkbox. You're given each checkbox here on the browser. Each one of these corresponds to a dependency here, right? Each dependency is auto-imported for you. But you notice that there was no support. There's no text, no checkbox for testing, right? I don't have to bring that in. It's assumed that in 2019 that you're going to write tests. You are going to write tests, aren't you? Good. Let's say yes. Is it da? Da. Okay. So you're going to write tests. You don't get to, like by default, we assume you're going to bring this in, and that brings in all sorts of good stuff. It brings in JUnit. It brings in Hamcrest. It brings in all sorts of good stuff for testing web applications, or just applications in general. So I've got this test, and this is already created for me, and it's a nice test, but it's not a good one. It's not the one we want. So we're going to start with a very simple test called Reservation Pojo test. Okay, so we're going to have the same domain as earlier, but we're going to prove that we can create a valid Java object. That's all I want to do, is create a valid Java object like so. Okay, and the way I'm going to do this is I'm going to create a new reservation like this, and I'll just create a new object. And you notice that as I'm writing, I'm already getting test failures. Compilation failures are test failures. So I need to create this class like that, okay? So private string ID, right? Private string name, good stuff. So there's my basic entity, and I want to prove that if I pass in an ID and a name, I get a valid result. Well, of course, I've got a compilation error. I can go back here and I could do this the old-fashioned way, but as you know, I much prefer to use Lombok, right? So I'll use that instead, right? Makes it a little bit easier. Now, I've got an entity, and I want to make sure that, certain things about this are as I expect. I want to make sure that the ID is equal to 1. I want to make sure that the name is equal to Jane, and that could work just fine, right? I can actually run this code right now. Here we go. And this is just a basic JUnit test. Nothing fancy, nothing about Spring at all here. And it worked. You should prove that it worked by testing the negative, right? You break it to make sure that when you get a positive result, that your tests are working, okay? So there you go. So I broke it, and it worked, right? Or it failed as it should have. Now, this is basic JUnit. Another option that you have is to use the assert that. I quite like the assert that. So you can say, get the name, and then you pass in a matcher from a project called Hamcrest. So here, I want to say that the name is equal to, ignoring case, Jane, okay? Let's run that test again. Okay, that worked fine. Break it just to make sure. Now, matchers are great because they are pre-written recipes for tests. You can give them something, and then there's an object there that has a recipe for testing the thing that you want to test. So if your test is more complex than a Boolean or a number or a comparison or is not null or something like that, then matchers are great. You can create your own matchers too, right? You can easily do that. You can say, okay, I'm going to create my own matcher. The thing that you should not do is extend matcher, okay? You can see that they're trying to communicate with us. That's them trying to tell us something. I feel like the Java docs would have been a better place to put that, but whatever, okay? So if you want to create your own matcher, you can see the API is very reasonable, right? It's a very simple thing. It says, given a test, given a thing of type T, prove that T is equal to something I care about, right? Is it not null? Does it match a certain condition, right? And if it doesn't work, then you can provide a description. You can say, it was null, right? You can actually emit the description. So now you don't have to constantly recreate this simple test that you use throughout your code base, okay? You can just describe it in a matcher and then reuse that. Whatever you do, is fine, right? We've got now a very simple test that proves that I can create a valid Java object and that I can create the constructor and all that stuff. Now, what about persistence? I want to persist this into the database. So I'm going to create a reservation document test. Okay, document test. And this document test is going to be a very simple thing. I'm going to say, I want to persist the data in MongoDB. And in order to test it, in order to persist it, I'm going to use the reservation repository. Now, of course, I don't have a reservation repository, so we need to create that, right? Test-driven development. Here we go. Just like before, right? Extends the reactive CRUD repository, managing entities of type string. Good stuff. Okay, there's my basic entity. And I can either create the machinery required to create this repository myself, or I could create I could actually, right now with Spring Data, I just have an interface. I don't have the actual implementation. I could get the implementation, but then I would have to recreate all the stuff that Spring Data is going to do for me. So instead of doing that, I'd much rather let Spring do that work for me. I'd much rather let Spring create the object for me. So what I'm going to do is I'm going to say, this is a test that's going to be run with the Spring runner. Now, the problem is that Spring Boot is very, very expansive. It's going to do all sorts of good things for me. It's going to create my database connection. It's going to create my web service. It's going to create the controllers and the validation and all of that stuff. I don't want all of that stuff being created just to test the persistence. So in Spring Boot 1.4, we introduced something called a test slice. Normally, you would say Spring Boot test, and that starts up the whole Spring application. Instead, though, I'm just going to use the test slice from MongoDB. So when I go to this test slice, you can see it says that it's going to auto-configure only the MongoDB and only the cache support. It's going to disable everything else, right? You can see it says auto-configuration, override auto-configuration, enabled equals false. So that means all the default auto-configuration that Spring Boot comes with is going to be disabled. It's only going to enable the MongoDB stuff. There are filters that are going to look in the application context and find objects of a certain type that are related to the data tier, right? And there are lots of different test slices that activate for different kinds of use cases. Here, I'm only testing my interaction with the MongoDB database. So now I can just inject this repository and use it in my test, and I don't have to load the whole web server. So let's try it. Let's see. This.reservation repository.saveAll, right? I can pass in a new reservation, like that, and I'll pass in null, pass in Jane. And what I want to do is I want to prove, just save. What I want to do is I want to prove that this worked. But if you came to our talk earlier, you know that this is an asynchronous thing. It's going to publish data asynchronously. So I guess I could try doing jane.subscribe. That's weird because, again, if I do this, there's no guarantee that I will get the results before the test finishes here, right? The test might finish before the actual result comes back. I could do jane.block, but every time I do that, it makes me want to take a shower. So don't block. You should never block on purpose if you can help it. So instead, you use the step verifier. You say, verify Jane, expect that the next value will match a certain thing. So expect matches, and then you can provide a new predicate, a new Java 8 predicate, okay? And the test, anything, you can test anything you want here. You can say reservation.getID is not null, and reservation.getName equals ignore case Jane, right? And then finally, I want to verify that the reactive stream completed normally, as we expected to. So of course, this lends itself to being a lambda, so I'll just rewrite it as a lambda. Very good. Good stuff. So now I've got this. Let's see if that works. Let's run this test. This is a reservation entity test, reservation document test, okay? Let's see if that worked. And there are other different things you can call. You can say, I want to expect this object will be returned. I want to expect a certain count. I want to expect that there's an error. All sorts of things you can expect or assert. Let's say that I change this. Let's say that this is now, it should be null. Okay, I'm going to run the same test again now that I've changed that code. Let's see what happens. So it broke. So we know it's working, right? It's doing the right thing. Good. So now we've got proof that we're able to persist data in the database, right? And I'm using one of many different test slices. You can use all sorts of different test slices in Spring Boot, and you can create your own as well. It's very simple. Just take a look at one of these and reuse, right? Now, I've got data in the database. Now what? Well, I want to create an HTTP API, okay? When I create this HTTP API, it's just an HTTP service. I'm going to say reservation HTTP test. And again, what I want to test is only the web tier. I don't care about the rest of the application. I just want to test the web tier. So I'm going to use, the webflux test annotation and the run with Spring Runner annotation .class. Okay, and when I do that, I'm going to write a test that proves that when I call to get all the reservation data, that I get the data back. Okay, so there's all the data, and I'm going to inject my web test client This is a mock HTTP client. It's not going to actually open up a network call and do all that stuff. It can if you want it to, but it's just going to make a call to my service, to my machinery, to the actual API itself, to the Spring layer. So here we go, web test client.get.uri, HTTP, or even better, just do this if you want, right? And I'm going to say that I want the data to come back, and when the data comes back, I want to assert that the data is okay, that it has status code 200. I want to assert that the content type is equal to application JSON, and I want to assert that the body has a certain shape. I'm going to prove what shape it has by using JSON path. How many of you know JSON path? It's like XPath. It's a way to declaratively, with a pattern, kind of iterate over the structure of your JSON document and prove that certain data exists in certain places. So I'm going to say that I expect this to match a certain pattern, right? There you go. So that's my test. Let's see what happens when I run this. This isn't going to work, of course, for a number of reasons, right? There's a lot of reasons why it's not going to work, but let's just run it just to see, okay? All right, so first things first. The class reservation HTTP test is not public. Oh yeah, that's true. Okay. Okay. So what happened now? What happened now? If we go down here, it's going to say, of course, that the class doesn't exist, that the HTTP endpoint doesn't exist. Good point. So we're going to go back to our production code, and you're going to find, like a lot of times, what people will do in this case, again, I'm doing test-driven development by myself. A lot of times, people will actually set up two screens. If they pair program with somebody, it's very convenient to have two screens and two mice and two keyboards and to go back and forth, right? We call this red-green refactoring. I'm doing this by myself with just my, just me on stage, but it's very easy to do red-green refactoring. So one person makes the test or writes the test, and that test fails. And then as soon as it fails, somebody else, the next person, writes the code in production code that makes the test pass. So I make it red, you make it green, and we go back and forth, right? Ping pong. Okay? It's a very common thing to do. And if you're doing it by yourself, you can kind of get that effect. IntelliJ makes it pretty easy. So if I go back to, for example, if I have a feature in my code that I want to test, you can actually go back and forth between objects in production code and in test code by doing Command-Shift-T on Mac, right? It'll actually switch back and forth. Unfortunately, I don't have a thing called a reservation document in the production code, but if I did, I can do Command-Shift-T and go to reservation document.java, and then Command-Shift-T again, it'll go to reservation document test.java. Okay, so now I've got this HTTP endpoint, and you can see I need to have some production code. So I'm going to go back to my production code, and I'll create the reservation HTTP configuration. Okay, and here it's just a bean. I'm creating the router function, just like earlier. I'm going to create some endpoints here, and I'm going to return some data by injecting the reservation repository. Okay, RR return route. Okay, .build. Good. So now I'm going to say .get/reservations new handler function return server response.ok.body rr.findAll reservation.class. Okay, so that's just very straightforward functional reactive HTTP endpoint, just like before. Now let's run this code. Let's see what we get. So we're going to run the reservation HTTP test. Will that work? Let's see. Okay, so that still failed, and you can guess why. So remember, we're using a test slice. So let's go to the test. We didn't. You know why? We didn't actually have we have to import our reservation HTTP configuration, right? So remember, because of the test slice, Spring is not loading everything that it would normally load. It's loading the most minimal amount of things that it can possibly load. In this case, it's only loading the Spring Web Flux stack. It doesn't know about all the other configuration classes, and it doesn't know about all the other beans related to data processing and MongoDB and all that. So if you look at this, you can see it tried to load the application context, and it failed because there's no bean of type reservation repository, right? It only loaded the web tier. There's no data type. There's no data repository in the application context when it starts up. And so what we need to do is we need to have a reservation repository. You can see we've got it here, and you can see that we use it here, right? We inject the reservation repository there, and yet when I start up my application, this bean doesn't exist. So one thing that I could do is use a mock, right? A mock object is a thing that fills a certain shape. It has the shape of a thing that I want to use in my code base. I could certainly do that. I could create a mock object. And then I would create a configuration class, and I would define an @bean, and then I would return the mock object, and so on. This is very painful. I don't like to do that. It takes too long, and plus you have to slice and dice your application context so you can exclude parts of it, and so on. So in Spring Boot 1.4, we introduced something called mock bean. Mock bean lets you use Mockito, right? I'm using Mockito here. Spring Boot is going to find this bean. It's going to see that I've got an annotated @mockbean field, reservation repository, and it's going to say, oh, you want a Mockito mock of this type, of this interface. It's going to create that bean and register it in the application context for you. If you have a bean of the same type already, it'll replace it. If you don't have that bean in the context, it'll add it, right? So this is very useful. So now I've got a Mockito mock in the Spring application context. And even though I said I want a mock, I don't really want a mock, do I? You know what a mock is? A mock is just a Java object that has the shape of something that we need in our tests, right? We need a foo or a bar or whatever, right? These things they pass the non-null checks. They return 0 or false or empty strings or whatever, but they're not actually doing anything. They don't know how to do what the real objects do. They just are stand-ins. I don't want a mock. What I need is a thing that can react or behave in a certain way. This is not a mock. It's called a stub. So I'm going to say Mockito when find all, then return flux.just new reservation 1 Jane. Okay, so I'm providing a stub. This is I'm stubbing the call to find all. Okay, so let's run this test one more time. Let's see if that fixes it. Okay, that worked. It was super fast. I was able to mock out the thing that was expensive, which is the call to the database, and I was up and running. I got the whole thing ran in less than a second. I couldn't even drink water, right? So now I've got a green service. I'm able to talk to the database. I'm able to test asynchronous things using the step verifier. I'm able to poke at the state of the JSON documents that come back. All would seem to be okay. So what I want to do now is I want to build a client. Okay, I'm going to go back to start.spring.io, and I'll build a client that talks to that service. Okay, I'm going to say client. I'm going to bring in the latest and greatest version of Java because it's the right thing to do. I'm going to use Lombok. I'm going to use the reactive web support, and I'm going to use the stub runner. Okay, we're going to bring in this Spring Cloud Contract stub runner, and let's hit generate. Okay, it's going to create a new project. UAO client.zip. Good stuff. Now, this client application is just going to test my client that I'm going to build for the application, for the service. Microservice organizations do this all the time. They'll create a client, and the client will be a sort of blessed client, right? It's a thing that everybody in the organization trusts to make correct calls to the service. You don't have to use it, but it's very useful, okay? So let's get rid of that. This is now this public, enable auto import, okay? And we're going to run this with a Spring Runner. Just run with springrunner.class. Good stuff. So there's this, okay? Now, here's my client application. In order to make this work, I'm going to inject my reservation client, which of course we have not defined, right? So client, here we are. In order to define it, I'm going to just hit Alt-Enter, hit Create Class, and there we go. There's the bean that I'm going to create. I'm going to do flux of reservation, get all reservations. Okay, so it's a client. In order to do this, I need to have the DTO, so I'll create that here. Private string ID, reservation name, and voila. Okay. Now, @data, @allargs constructor, @noargs constructor. And in order to make this network call, I'm going to use the reactive HTTP client that we have in Spring Web Flux. It's called Web Client. It's like if you have to make a reactive client call to an HTTP service, use Web Client. It's awesome. I'm going to add this into the constructor, like that. Now I've got this. Let's say return null for now. Here, I'm going to then load the data. I'm going to say client.getAllReservations. There's the data, right? And I want to make sure that when I call that service, I get certain data back. Let's just say that I'm expecting that the next record that comes back will look like the ones that we've been testing. So reservation.getID should not be null, and reservation.get reservation name should be equal to Jane, okay? And I'm going to verify complete. Now, let's run this code. Good stuff, right? Let's run that code, and let's see what we get. This is going to fail, okay? It's going to fail catastrophically, but that's okay. Let's see why it fails. Okay, so first of all, I have the wrong test type on the class path. So I used JUnit Jupyter from JUnit 5. I meant to use the old JUnit 4 API, okay? So there's this. I'm going to bring in the client application test, run that again. Okay, so now what happened? Well, if we look at the console here, friends, you can see that, whoa. There, it gave me an auto configuration report, which is nice, but not nearly what I wanted. There we go, there's the error. So it's saying that it can't find a bean of type reservation client, right? I haven't actually made this part of the Spring application context. No problem. Try again. Okay. It's still going to fail, right? We know why. Because it needs a web client, right? There's no web client, so let's actually create this in the actual client application here. Good. Web client. Web client.builder. Turn builder.connect, builder.build. Run the test again. And of course, still going to fail, right? Let's see. Now what do we got? We should have a null pointer. Yep, there we are. There's a null pointer. So now we say, okay, let's make a network call. Let's do it. This.client.get.uri localhost 8080/reservations, right? Reservations. Dot retrieve dot body to flux reservation dot class. Okay, run that again. Good stuff. Good stuff. Now, still failed. Look at that. It failed. It failed because it couldn't connect to the host. It couldn't connect to the host because I'm not running the service. Well, this gets us into a bit of a problem, doesn't it? Now we have a bit of a problem, something that I'm sure you've probably experienced before. And this is a very big problem because now, in order to test this simple client, I need to run the service. And this is just a very simple example. Imagine a more complex example. Imagine a more complicated, sophisticated example with more than one moving part. This is a useful time, I think, for us to take just a moment and talk about culture. I don't know much about your wonderful culture, but I'll tell you about mine. I live in San Francisco in the United States. And in San Francisco, in Silicon Valley, if somebody comes into your organization as a new employee, if they come to your office, it's very polite, it's very warm, it's very welcoming to tell these people, hello, welcome, come on in, have a seat, here's some coffee. It's very friendly, okay? It's a very friendly thing to do. But if you have somebody who comes into your organization and they join your organization and they're hopeful, they have hope, nothing takes away that hope. Nothing is more vulgar, more rude than the following. Welcome, come on in, have a seat, here's some coffee, here's your desk. Now please deploy this Kubernetes cluster to test your service. Nothing is more rude. I'm not sure if that's the same here, but I have seen people leave, they've quit jobs that they just took, right? Nothing is more rude. Very vulgar. So I don't want to deploy my Kubernetes cluster just to be able to test my little service. This is just a client to a service. Can you imagine if it was more sophisticated? Right? Can you imagine trying to build an iPhone application and somebody says, here, deploy these 500 microservices, right? And all their data and all their databases and message queues and security and all that stuff. you would lose friends very quickly. So instead of doing that, one option is to mock out the API, okay? So I've got this client application test, and one thing I can do is to use something called wire mock. So I'm going to say @autoconfigure wire mock, port 8080. And when I go here, I'll say wire mock dot stub4 wire mock dot get wire mock URL equal to reservations. It's not our API. Dot will return wiremock dot a response dot with header HTTP headers. And somebody else thought of this. See how many headers there are? It's insane. So, okay, here we go. There, that one. Content type, media type, dot application JSON UTF value. Okay, so I'm going to say that's the header. With body, I'm going to come back to that in a second, and with status. Okay, so with status, HTTP status dot OK dot value. Now I've got this body, right? I need to have the body there. It's a string. It's going to be a body. You can clean this up a little bit, by the way. You can say add static import, and that's kind of nice. So there you go. That's a little bit better-ish, right? But I need to create a body. So var body equals, and then I'm going to create I cannot wait for multi-line strings to be GA, right? Like a real thing. But for now, we'll just do it the old-fashioned way. So I'm going to create a JSON string, right? Like so. All right, so we've got this JSON object. The first pair of attributes is ID 1 and reservation name, Jane. Okay, so there's my JSON body. There we go. Okay, so that's my new API. Let's run this again. Let's see what happens. Good, that worked. Nice, huh? So now we're using wiremock to stub out this collaborating object because we're not actually trying to test the service. We've already done that. I've already gone to the production service. I've already gone to that service. All the tests are green there. I'm trying to test that when I make a network call across the wire, that the client of that API works as expected. And if you're doing this in the servlet world, if you're doing this in a non-reactive world, we have something called a mock REST server, right? You can use that as well. This is an okay approach for third-party APIs, especially, right? APIs that are fairly stable, right? So if you're trying to test against like Facebook's API or Twitter or something like that, right? Or GitHub, these APIs are fairly stable, so you can mock them out. The problem, my friend, is that when you're inside of an organization where different teams are moving at different speeds, there's no guarantee that your third-party API, the API against which you're making these requests, there's no guarantee that that API is going to be stable. Actually, quite the opposite, right? There's a bit of a bug in this code, isn't there? Bit of a problem in what I've shown you here. I've got a client and I've got a service, and they're both green, and yet I guarantee you they won't work in production. And the reason is because on the client here, I've been using reservation, and the DTO has a field called the reservation name. On the server side, over here, in the producer, it's just name, right? So this is a bit of a problem. They're both green, and yet they won't work together. So now I'm back to the first situation. I'm back to square one. Do I need to have, do I need to deploy that Kubernetes cluster after all? In a microservices world, you want to test everything, but now you've got all these network interactions, and those interactions can be very slow. That's the top of the testing pyramid, and we don't want to have everything become a slow network call. So instead, we need some way to test the interactions between our APIs, and we need some way to be confident that if something breaks, we'll be able to detect it. If we were doing this inside of a monolithic application, then the compiler would help us detect whether something is broken or not. If we change something here, the compiler would say, hey, you can't call that field or that method because it no longer exists. But we don't have a compiler here. So what we're going to do is we're going to use something called Spring Cloud Contract. Spring Cloud Contract is sort of like the compiler that helps you catch integration breakages, okay? So let's go back to my producer. And I'm going to create a contract. I've got on the class path, I've got Spring Cloud Contract Verifier, Spring Cloud Starter Contract Verifier. And so what I'm going to do is I'm going to go to my test folder here. There's a folder called contracts that was already created for me. And I'm going to create a file called should return all reservations.groovy. Now, a contract is a definition of a test, okay? It's a very declarative test. It says, I expect that when a request comes in that looks like this, that I'll get a response that looks like this. And so you write the declaration using a DSL. I'm using the Groovy DSL. There's also a Java DSL, a Kotlin DSL. There's even a property file DSL or a YAML DSL in case you really, really don't value your own free time. So you can do whatever you want. I'm going to use the Groovy one because it's nice. I'm going to say this should return all reservations, okay? And I'm going to describe a request and a response. Now keep in mind, this is a DSL, but it's going to be turned into a unit test, okay? So what we're describing is we're saying, hey, when a request comes in that looks like this, or we can use a string, I guess, that's deprecated now, get. When a request comes in that looks like that, and that goes to this URL, then I want to make sure that the response has a status like this, okay? And that the headers include a content type equal to media type application JSON, and that the body looks like this. I could do a string here, right? It's fine, but Groovy has a very nice syntax for literal objects, object literals, that looks kind of like JSON. So you can actually do something like this, and it works just fine, right? So ID1 name Jane, right? It's not exactly JSON. This is a collection, and that's a map. But behind the scenes, the contract DSL knows what you're trying to do. So I've got this contract definition. This contract definition is, it's a test that's going to be created for us automatically because of the Spring Cloud Contract Maven plugin. Now, a couple things that we need to configure here. First of all, this has to be explicit, right? And the problem with this contract is that when we run this contract, it's going to be turned into a test, but that test doesn't know about the rest of what we have done. It doesn't know about the Spring application context. It doesn't know anything. So let's see what happens when we try and build that producer on the class path here, on the command line, I mean. All right. So hopefully, we'll see a result. It's going to fail. Okay, good. And when it fails, you can see it fails in the contract verifier test class. So let's find that class. Contract verifier test.java. Okay? And you cat this file out, cat that out, you can see it's a regular test. It's a test that has a public void test, and it says, hey, when a request for /reservations comes in, I expect the status code to be equal to 200. I expect the content type to be equal to application JSON. I expect the body to have a JSON structure with an ID equal to 1 and a name equal to Jane, right? That contract is actually a test. And you can create lots of contracts. You can create thousands of them. They're very cheap, right? And each contract captures one exchange that you expect to work. And this is great when you move fast, because if you break something in the API, these contracts will fail the build. They'll help you capture a breaking change in the build. They also do the same thing as our HTTP test did earlier, right? So we didn't need to write that HTTP test. We could have just written a contract. The other benefit of this, of course, is that if you're moving from one version to another, but you want to make sure that you don't break the old version of the API, these contracts will capture that change, okay? And they'll capture the old version of the API. So you can make sure you have contracts for version 1, or even if you have some older clients that rely on some weird behavior in the old API, you can confirm that that works with these contracts. Okay, so that's the contract, and you can see that it doesn't know about Spring. There's no base class. It doesn't extend anything. So what we need to do is to tell it to extend a base class, and that base class will set up our Spring application context. It'll set up everything that's required to do the work that we want to do. So we're going to say that this is just a Spring Boot test. We're going to say it's going to run with a Spring runner. We're going to say that this is going to be a before method, so it's a setup method, right? Okay, and we're going to do a few things. We're going to inject the port on which the Spring Boot application is going to run. Okay, so I'm going to say, there's two ways you could do this. You could say properties equals server.port equals 0, or you could do web environment like this, and I want to do random port. So random port or 0 both mean do on a random port. I also want to bring in the HTTP configuration, the reservation HTTP configuration. There we go. So there's my port, there's my setup, and what I'm going to do is I'm going to say, okay, first of all, I'm going to use the Spring Cloud Contract HTTP client API, which is called Rest Assured. I'm going to configure it to talk to this host and port for all of its interactions. And then second of all, I am going to just do Mockito again. I'm going to do the same thing I did in my HTTP test. I'll say, let's copy this. Okay, base class. I'm going to do @mockbean, private reservation repository, and voila. Okay, there's the entire thing. Good. Okay, there you go. There's the actual interaction. Now this base class, I need to tell Spring Cloud Contracts Maven plugin about it. So I say base class for test. Now I'm using one base class for all of them, but you can do all sorts of different things. There's different patterns that you can specify. You can say, oh well, if the class starts with this, then find something else that has the same prefix and then a common suffix or whatever. There's all sorts of different configuration options here. Now let's try this again. Maven clean package. Actually, let's do Maven clean install just in case. Okay, fingers and eyes crossed. Good stuff. So that worked. Now, that installed the Maven pom.xml. It installed the jar. What's interesting is that it installed the stub as well. The stub is a WireMock definition. It's a config file that you can give to WireMock. Remember what WireMock did. WireMock creates a fake HTTP service. It's an actual HTTP service. It's on a port. It's got a socket and everything. But it has pre-programmed data. We told it to say the following. We told it to respond with the following JSON whenever somebody connects to that service, right? So now we've run this contract, and because the contract matches our actual API, we've told it to install a stub, which is the WireMock definition, into our Maven repository. You can use Nexus or Artifactory, right? Artifactory is a nice choice there. You can use your local M2 repository, but imagine that you're in an organization. You're inside of an organization. One team installs, they do a git commit. The git commit goes into the CI environment. The code gets built and compiled, and then your application, because you do continuous delivery, right? When you do continuous delivery, your code gets pushed into production. So at the same time as you do continuous delivery and deploy into production, you also have your artifact installed in your organization's Artifactory environment. So now I want to take advantage of that as a client. Okay? So now I'm going to go back here in my reservation client test, and I'm going to use the stub runner. I'm going to say auto-configure stub runner. And here, I'm going to give it the Maven coordinates, right? This is the group ID. And what was the artifact ID? It was producer, right? So the artifact ID is producer. And I'm going to tell it to use the latest one in the repository. That's this plus sign. I'm going to tell it to run on port 8080. And with that, I'm also going to tell it to run and check the local repository. I could do class path, I could do my Artifactory, or I could do local M2, right? So this is actually going to run the Maven, resolver when the test is run. This is actually going to run the whole thing. It's going to find that stub that we installed here at this artifact coordinate, right? And it's going to start it up, which means I don't need this anymore, right? So there we go. Okay, what happened, huh? So let's see. I got a null, didn't I? Null pointer exception. So the contract caught the bug. I'm expecting reservation name to be equal to Jane. There is no reservation name. It says reservation name equals null. Okay, the contract helped me catch the bug. I'll fix this. This is broken. Back to name. Let's run this test again. Okay, there we go. It's green. See? The contract helped us capture breaking changes between one service and another. Now, I have been using Spring Cloud Contract, and it works great with any JVM language. I was using Groovy, and you can use Kotlin and Java and all this good stuff. I happen to think this is a very nice choice, but you may still be wondering, okay, Josh, what about those poor people using some other non-Spring Java JVM world? I haven't seen this in practice, but apparently it's a thing. Who knows? Maybe there really are people that aren't using Spring. I believe it's possible. So, for those people who are not using this, then it's not going to be useful to run, the Spring Cloud Contract stub runner. So we provide a jar that you can distribute, right? Bin, Josh bin, Spring Cloud, CD Cloud, Spring, there we go, and CD Spring Cloud Contract. So you have a jar called Spring Cloud Contract Stub Runner Boot. You can Google that and find it, and you can use it very easily. Here's what it looks like. You say Java-jar, I'm going to give it a port, I'm going to give it the jar itself, of course. I'm going to then provide all the same parameters as I did in the auto-configure stub runner, and I'm going to give it the coordinates, com example producer plus 8080. It's going to resolve the artifact stubs in my local M2 repository. That's what this is. It says local, right? And it's going to start up an actual web server, right? So here we go. Run that. Now, localhost reservations. So now, if I have one contract or thousands of contracts, all those endpoints will be right there. So now somebody who's testing their iPhone development or HTML5 or Android development or whatever, you don't have to tell them to deploy the Kubernetes cluster. You can tell them, here's a little jar, start it up, and it'll give you actual data that looks and feels exactly like running the real system. And we know that it works because the real system would not compile, the build would not work if this contract wasn't correct. This allows them to be able to move forward quickly. So using contracts is a very, very powerful way for you to confirm that one system matches another. This has several benefits. I wrote the contract, and then the contract generated the test. But you can also do it the other way around. You can write the test and have that generate the contract. Another thing that's really nice about Spring Cloud Contract is that it also works for messaging, right? People often say, oh, well, the reason you had this problem is because you're doing HTTP. Maybe if you were using Kafka or RabbitMQ, then your problems would be magically solved, right? That's nonsense. It's patent nonsense. You have a producer and a consumer. They both must exchange a message. That message is the contract. So you can use Spring Cloud Contract to mock out messaging technologies as well, right? With the same effect. You can actually say, when a message comes in on a Spring Framework channel, message channel, then I expect the following results. You can use Spring Cloud Contract in conjunction with Spring REST docs. So you can write your documentation inside of your tests. Now you get contracts and you get documentation, and you can do it in the test-driven style. So as you're developing, once it's green, you're done. You can go home early. Thank you, my friends. I hope you learned something. Who learned something new? Who learned something new? Good stuff. Good stuff. Who had fun? All right, very good. Pasibos, thank you so much, my friends. I'm happy to answer questions.